What if I told you that a scientific problem so tough that people called it impossible for more than 100 years has just been cracked by an AI model? A problem so famous it carried $1 million prize for anyone who could solve it, and yet mathematicians around the world came up empty until now. This is the story of how an AI stepped in and solved part of the Navier-Stokes equations, one of the hardest mysteries in physics and mathematics, unlocking discoveries that could reshape weather prediction, aircraft design, and even our understanding of the universe. For over a century, researchers wrestled with the equations of fluid motion. These equations, called Navier-Stokes, describe how air, water, and gases flow. But the nightmare was the possibility of singularities, blow-ups where velocity or pressure goes to infinity. Humans tried for decades to prove whether these singularities exist, but every attempt failed. Then DeepMind took a different route. Instead of brute forcing with supercomputers, they trained physics-informed neural networks. AI models check directly against the laws of physics. By minimizing the gap between prediction and equation, the system uncovered entirely new families of singularities that had never been described before. Mathematicians at New York University, Brown, and Stanford verified these solutions, confirming they were mathematically solid. That means this was not an AI illusion, but a genuine breakthrough. The model even found hidden patterns inside the singularities. By tracking a parameter called lambda, it revealed regular structures across different equations, from porous media flows to the full Navier-Stokes. These patterns suggest an entire landscape of singularities waiting to be mapped. What makes the discovery more striking is that the singularities uncovered are unstable, requiring near-perfect conditions, but this fragility reveals deep truths about the structure of fluid equations. The accuracy was mind-blowing compared to predicting the diameter of Earth and being off by just a few centimeters. To achieve that, researchers pushed machine learning networks to near-machine precision using advanced optimizers. The result is a level of detail never accessible before, letting scientists watch vorticity fields evolve and slice through blowups in ways that bring the math to life. This is not just about math, it is about what AI can now do in science. For the first time, an AI acted like a research partner, exploring equations too vast for humans to navigate, flagging possible solutions, and letting mathematicians step in to confirm them. As one lead researcher said, the AI turned from a problem-solving tool into a discovery engine. That could change the way proofs are done, combining human intuition with machine precision. The implications go far. In meteorology, it could sharpen storm forecasts. In aeronautics, it could lead to more fuel-efficient aircraft. In astrophysics, it could illuminate how gases swirl around stars and black holes. At the same time, the breakthrough raises new questions about how far AI should go in fundamental science. If machines can tackle problems thought impossible, then research itself is entering a new era. So here is the question. If AI can solve a 100-year-old mystery in fluid dynamics, what other frontiers once thought unreachable could it unlock next? Share your thoughts in the comments, and if you want to keep up with the biggest breakthroughs at the edge of AI and science, do not forget to like and subscribe to Bon Bon AI.